All right. Well, if we want to move from the settings onto the results, well, you can see, wow, there's like, what, 6 different graphs that you can see? So is it always 6 graphs that you get?
Yeah, it's always 6 graphs, and each time you click the results tab, it computes again the results. Like you can see, it takes some time.
All right. So if we look at the graphs, you know, what kinds of things you can actually read from them. Well, if I look at it quickly, it looks like the x-axis always seems to have the year.
That's right. In all the 6 graphs, it's time running in the horizontal axis.
And it seems to be it seems to be the same as the time span that we set in the settings.
That's right, from 2020 to 2100.
All right. And then it looks like the y-axis is changing, obviously, between the graphs. So in the first graph, it's area.
Yeah, it's area, but in all the 5 remaining other graphs, it's carbon density. The scale varies. The scale comes automatically, but it's always carbon density in the 5 ones. The first is different, it's area.
Okay. So what are the lines?
Yeah, you can see there are 2 lines in most of these graphs, for example in the first one, and you can see the acronyms for forest and cropland are here in the legend. So forest is the darker color, the orange or whatever it is, red maybe, the red color. The line in red describes the area that is forest. So you can see, if you remember, in the land use change matrix, in the first period we had cropland converted into forest, 6% of the cropland every year. So you can see that forest area, it is really increasing, and the opposite is true for cropland.
All right. And then you can see like a sudden definite change at about 2050. So what is that?
Yeah, that's the year. If you remember, there were 2 land use change matrices. The first one, with the change from cropland to forest, goes until 2050. And during the second period, there was no land use change. So we can see it here. After 2050, there's no land use change. Cropland area remains constant, and the same is true for forest area. It remains constant.
I see. Okay, that's clear. So what about the next graph?
Well, you see the same colors. Forest is the orange one, and cropland is the yellow one. And now carbon density is in the vertical, in the y-axis. If you remember, do you remember what was the setting for carbon density for cropland? We can go back and see from the top table, 5.0. So cropland biomass carbon density at equilibrium was 5. And you see 5 here. The line is all the time at 5.
All right.
Do you remember what was the setting, our setting for forest equilibrium carbon density? We can go and have a look. It was 100. So and something funny happens here. Can you guess what it is, or should I explain?
Maybe you should explain.
Yeah, you see, the first year there's area which used to be forest in the beginning. All the forest is area that has been forest for a long time. That's the assumption here. And what happens after that, like you see in the top left, there's forest area is increasing. So there's cropland converted, afforested. And these new forests have smaller trees. And because we have this assumption that only 3% of the difference to the equilibrium carbon density happens annually, therefore, the change is not sudden. There's more and more young forest, but all these young forests are growing at the same time. So the first year, 2020, there's new forest, and that is growing, but there's more and more new forest in other parts of the landscape. And that area is increasing so fast that the average carbon density in all the forests is going down until something like is this 2035, around then, and then it reverses slowly, because the oldest of these new forests start to be so old that they are growing more and more, and therefore the average carbon density in the whole landscape goes up, starts to increase. And can you see something here?
Yeah, there's like a small little deviation.
Yeah, that's the location. That's 2050 again. That's the year when land use change is assumed not to happen after that period.
Right.
And after that, carbon density in the forests still increases, like you can see, and faster than prior to that turning point. But and it approaches the set equilibrium carbon density, which was 100. It approaches this level asymptotically, like this. And if we would do the simulation for, let's say, 2500, we would see it already at very close to 100. It never quite reaches 100 exactly, but it goes very, very close.
All right. What about the next one?
Yeah, that's the same picture. Actually, no need to look at that. I think you understand it quite clearly, because it's the same, but for soil carbon. The previous one was for biomass. So we can check our assumptions, our settings for soil carbon density for cropland and forestland. Let's go back. So they were 50 and 30. If we go to the results, you can see that the same thing as in this top right panel, but now these lines are closer to each other, because also the carbon equilibrium density difference is much smaller.
Okay.
The same thing.
All right. Is there something special about the next one?
Yeah, that's something different. Slightly more difficult to understand. Yeah, again, there's carbon density and there's year. So the same axis as in the previous ones, but now it's about average carbon density. For example, this orange line is average carbon density in the whole landscape, not only in forests, but carbon in forests in the whole landscapes per hectare, for example, if that's your unit, like in our case. So you can see that. So it's the area multiplied by carbon density.
I see.
So you see that in the beginning there's less forest area than cropland, much less, but because carbon density is much higher, so there's more carbon in forests than in croplands. And this orange line, carbon in forests, increases from the beginning, because there's the old forests, they still have the carbon they had before, and then there are these new forests coming, which initially have very little carbon, and then they start to be a larger and larger area of forests, and all these new forests have increasing carbon densities, and then it approaches again an equilibrium.
All right. Well, what about the next one?
Yeah, that's again the same story, but with soil, like you can see from the title. Biomass carbon density in the whole landscape and soil carbon density in the whole landscape.
Right. All right.
So in this case, you can see that initially there was more carbon in croplands, in soils of croplands than in soils of forests. But the opposite is true at the end of the simulation period.
Right. Right. And the last one.
Yeah, this is maybe to many users, maybe to you as well. This is the most interesting graph, because here we can see the total carbon density in the landscape. So it's and here the legend is different, because there's biomass, soil, and total. So total is biomass plus soil. So the green line here is orange plus red. The total is here. And then the biomass graph here, or the biomass curve, comes from biomass carbon density in forests and croplands. That's the sum of these two. Like you can see at the end here, the orange one is close to 0 and the red line is close to 80. So the total here is close to 80. Not quite, but maybe 75 or so. Right. And with soil carbon, the increase is much smaller with this reforestation or afforestation, because croplands already, they had quite a lot of carbon in their soils